this is also used extensively for image processing applications. All right, so real heavy applications is what is the capability of this particular application. So on that note, I'd like to now invite Sharath to please take over. Please.
Thank you, Nitin. Thank you so much, and really appreciate you joining, even if when you're stuck in the traffic. Thank you so much for that. I'll take over from here. Thank you so much. Hi, everyone. Good evening, and welcome back to the channel. And as we promised, every weekend we will come up with one use case, one tool basically for deployment. And like we discussed in the last session, we will be taking up with the Docker and, of course, the FastAPI. We will focus heavily on FastAPI, and then we'll also talk about how Docker can allow us to do the deployment of ML models. We'll not jump into a lot of technicalities of, you can say, the Docker or the FastAPI, but we will see how these things can actually help us to bring our application into practice, so that the end users can actually use this using some web frameworks, web interfaces. So REST APIs have to be created, and when we talk about this REST APIs in Python, we have the three most important web frameworks, and Flask is something that we've spoken about the last session. And this week we were going to talk about the FastAPI. We also have Django, which is another full stack web framework development toolkit. We will pick it up probably in the next session. So we'll keep up that information up to date with you people. But this week is all about FastAPI. So let me share my screen and talk about what exactly is FastAPI. And let me start here. Okay. So there you go, friends. We are going to try and do deployment of machine learning models using the FastAPI and Docker. Of course, we will also have the intermediate things like Python programming, which is the heart and soul of the entire development. That's the programming language which we will be using. We'll have GitHub repository, though I'll not be talking about GitHub repository today. The same functionality will be there, like what we have seen in the last session. Just to ensure that the time is right, time constraints are considered. I'll skip GitHub related things for this particular session. We'll focus only on FastAPI and Docker. All right, so let me move on. The flow, as you can see on the screen, we basically are talking about the various social media channels that we have. Right? Just give me a second. I'll try and bring up something for you. Okay, so like you see in the on the screen, we have various data sources, right? And these data sources relentlessly get the data to us. I mean, they help us to get the data, right? And using this data, we will be trying and doing the training of our ML models. Now, when we talk about the data sources, we also have to understand that the format of the data, right, is definitely different from different sources that we are generating here. So, like you see here, the social media, majority of the data is unstructured. Then we have IoT devices which are generating the sensory data. The web sources, these are your social media, of course, is something that also is an internet, but we probably will have various web forums where the data gets collected, the applications, the forms that the business has. and the end users communicate the details using those web applications or different various forms that the websites contain. All these are in different formats. So we will have to ensure that we perform thorough ETL pipeline, right? The data pre-processing is also part of this. We will have to extract all this data, transform all this data, and then load it into, you can say OLTP. Or you can also have analytical processing system like your warehouses or data lakes. In our image, we are basically looking at OLTPs. So I'm bringing, excuse me, I'm bringing all the data from various sources into my database. So this is a data pipeline that we are constructing here. I'm demonstrating in a very simple format. Once the data is available in our database, we are going to try and fetch the data, perform the pre-processing using our Python programming language. We will apply auto PD techniques, auto data pre-processing techniques, and all those data pre-processing strategies will be implemented. And our raw data will be processed and will be made ready for model development. This is part of your CRISP-MLQ methodology. Post this, we will try and build the machine learning models. These could be regression or classification-based models, depending on what we are trying to achieve. And once the model is developed, the vanilla model is developed, we will try and evaluate it and try to improve it further by using various parameter optimization techniques, right? Hyperparameter tuning optimization techniques, like grid search, randomized search, Bayesian search techniques. We can also use auto ML techniques, which can basically run hundreds of experiments based on the number of parameters that we are trying to pass. Ultimately, we are going to get the best model. Right? This is your best model. After doing all the trial and run experimentations, you do the data partitioning, train, test, validation, right? And we try and use train and validation data to tune the model. Then finally, we check that on the test data, and we eventually get the best model. But this best model that we are speaking about is still in a naive mode. That is, it's just like a code. Now, end users require some kind of a web interface. Now, this is where Python allows us to create these web interfaces, the APIs, you can say, which are basically very easy to create. And when we talk about these REST APIs, the Python libraries allow us to generate these web interfaces very easily. We have lightweight web frameworks like Flask and FastAPI. We also have full stack web framework in Django. These are the most three popular web interface web frameworks that we can use to construct our APIs, web APIs, which we will do. I'm using FastAPI here. Once these entire code along with the web interfaces are ready, then we move this code into the code repository. This is where your entire code lies. So if you have multiple teams working on the same code or multiple people contributing onto the same code, then you need to have a centralized location where everybody can try and put their efforts into. So that is GitHub repository. We have seen this GitHub repository implementation or usage in detail in the last session. You can go through to get the quick intro into the GitHub repository. You just go to the previous video of this series. Now, once the repository is ready, once the final code is ready, we can use the Docker to try and create a container or a runtime image using containerization concept of on top of your ML model, right? On Docker, we can create an image. The advantage is that we will be using this Docker image in directly taking that application and placing it in different servers. Like it could be on your local premise, you can deploy it on local premise. You can take that same image and place that in any of the clouds, like your GCPs, AWS, or your IBM, IBM Cloud, or Oracle Cloud, or Azure Cloud, right? It could be any cloud, absolutely. So hardware independent, basically, right? So that is the advantage of having the Docker images. Now, once these are ready, you will be able to use the deployed application using the web interface that we have created, right? The FastAPI that we've used here to create a web interface. We will be able to access the functionality of the ML model using that web app. So we are basically talking about web API. But you can also create the end user interface by constructing or getting a mobile application developed, or you can talk about right, having a very simple interface where the end user can directly communicate with the model and all these things. So this is a very high level run through for the entire right, the flow that we are looking at here.